Hello YouTube, Rohan this side. So today I have a very interesting tool to cover, which is Kustomize. So Kustomize is an open source configuration management tool which is natively present for Kubernetes. So natively here means that you don't have to install it uh, specifically, like maybe using third-party manifest files. It comes within kubectl. So it is a native tool within Kubernetes cluster. So this tool allows us to define and manage Kubernetes objects such as deployments, daemon set, services, config map, and etc. for multiple environments in a declarative manner without modifying the original YAML files. So we can simply say that we have a single source of truth for all the YAMLs we have, and we just have to create patch files or patch configurations on top of the base YAML as per the environment requirements. Kustomize also let us to customize our raw template-free YAML file for multiple purposes as well. So let us have a look on its architecture, like how everything works. So this is a simple architecture of Kustomize, which helps us to deploy same application, means same base application within multiple environments. So here you can see that we have a single source of truth or Kustomize where we have already stored our base YAML manifest file, and if we have to specifically deploy or configure some YAML manifest file for dev environment, then with the use of Kustomize, we can deploy those patches or customize YAML manifest file into each of the environment we have. So here you can see that using Kustomize, we have created three stages or environments, and using Kustomize, we are uh, installing or deploying our application in these three different cluster as well. So one is dev cluster, another is staging cluster, and production cluster as well. So let us understand what is the concepts and what are the components which is play as backbone of Kustomize. So Kustomize has two key concepts. One is base and another is overlays. So base is, you can consider that base is a location or a directory where you have stored or saved your manifest file, and for the environments you have or the clusters you have, and they are just using some of the fields as customized specifically for the cluster or the environment. Then using those patches stored in overlays directory, you can use this customize. So here you can see with customize, we can reuse the base files or the common YAML manifest file across all environment, and overlay, which we can say as a patches specifications for each of those environments. Overlaying is the process of creating a customized version of the manifest file, and this is how the things work. Like we have a base manifest file plus overlay manifest file, which is uh, generating customized manifest file. And one thing we have to remember here is all customization specifications are contained within a customization.yaml file. So as we already aware of different type of resources and objects in Kubernetes, like deployment, services, daemon set, stateful set, etc. So within customize, we have to create a customization.yaml manifest file which specify that what all are the customization we are doing for the different stages. So this is a simple flow diagram which we can try to understand. So let us go step by step here. So see here in the first step we have base. So in the base, we have YAMLs with common fields required for all environments. So for the base, we have deployment.yaml, service.yaml, horizontal pod autoscaler.yaml, config and the customization YAML, which we have to create specifically when we are using Kustomize. After that, we have three clusters or three environments, which is dev, UAT, and prod. So using overlays concept, what we are doing is we have YAMLs with customization as per the environments. So in the same environment, we are passing or deploying the same YAML manifest file, which we have already created in base, but each of these YAML manifest file have some customization specifically to their environments. So those specification we have to uh, clarify or mention inside this customization.yaml, which we have created in each of the clusters here. After creating this customization.yaml for each of the environment, we are doing build customize manifest for each environment. So using customize, we are deploying the specific set of YAML manifest file to the specific dev cluster or UAT cluster as well as the prod cluster. So here, in short, you have created a set of deployment or YAML or any Kubernetes YAML manifest file with the customization.yaml. After that, you will create specific changes or the patches required for each of the environment or the stage in overlays. After that, using Kustomize, we are deploying these sets of YAML manifest file into their respective cluster. So this is a very simple tool to use, and it's a very good configuration management tool because it's very easy and easy to learn, easy to implement, and it does not require any other uh, knowledge which is not different from YAML. After this, we have a slide of like why to use Kustomize, what are the features they provide. So Kustomize, I have already told that it's a configuration tool with declarative configuration, same as Kubernetes YAML manifest file. So declarative configuration here simply means that we are declaring everything we want in a YAML manifest file, and according to the declaration we have done, we are getting the desired output. After that, uh, it can modify resources without altering the original files. So the original files are already present in a base location or the base directory. We are already only doing the configuration or modification inside overlays. After that, it can add common labels and annotation to all the resources. So common labels and annotations are required when you have to specify or query some specific labels, especially for your pods or your applications or even for environments. Suppose you have a label like that uh, namespace is dev, namespace is prod. So according to the labels, you can query and filter out what the label you are trying to search in your cluster. It can modify container images as well based on the environment it is being deployed in. So this is also a very good feature so that you have a different uh, container images for each of the application. Sorry, for your application, suppose you have a different container images which are specific to your environments so that you have a preview or you have versions of your applications running in each of your cluster. Kustomize also ships with secret generator and ConfigMap generator that uses environment file or key value pairs to create secrets in config. So this is also a very good feature of Kustomize, that if you have already mentioned your secrets as well as config map inside the base, and you want that whenever you are deploying these files or these YAML manifest file in your clusters or the namespace, then it will automatically create the secrets as well as config map in your cluster. So these are the feature of Kustomize. So if you are already aware of Helm, so you should definitely ask like, does not Helm work the same? Means if we have already Helm, then why to use this? So these are the points which I have written. Like Helm provides more advanced feature like hooks and release management, making it suitable for complex deployments. But in the case of Kustomize, it is simpler and more straightforward. Means it is very easy to implement. It is Kubernetes native, and it is very straightforward. You don't have to do much of the configuration inside your cluster. Helm has complex templating, which we all aware of, and Kustomize has no templating. So you just have to create two folders like base and overlays, and inside that you just have to store or save your YAML manifest file. After that, Kustomize does not need a separate setup. On the other hand, we need to set up Helm. Helm has a large collection of pre-built charts that can be easily shared and reused, while Kustomize allow you to share configuration but lack a centralized repository. So yeah, we are already know that we have Artifacts Hub where you can easily install Helm of any Docker base or any container based application inside your Kubernetes cluster. But in the case of Kustomize, you don't have any centralized repository where you are pushing or pulling any of pre-built or predefined templates. Kustomize has an easy learning curve, while Helm has difficulty as it introduces additional concepts like charts and templates. Kustomize uses overlays and patches to modify existing configurations, while Helm uses charts to package and manage applications. So these are the differences between Helm and Kustomize. I hope I was able to clear that how Kustomize work and how it is different from Helm. Don't worry, I have created a simple demo for this as well. So let us jump to my GitHub repository where I have created some base and overlays directories and deploy our application in our Kubernetes cluster. So here you can see I have created two directories. One is base and another is overlays. In the base, I have all the YAML manifest file required for my application to run. So it is consisting of deployment as well as service, which are self-explanatory here. I am just using deployment, and it is installing everything inside default namespace. I have a replica of one of my application, and I'm just using image nginx, which is of 1.14.2. I have a service for this deployment as well, and I am using notebook service type here. Nothing more much complex here. After this, okay, I have a customization.yaml manifest file for my base. So here, this is the API version of Kustomize, and the kind is customization here. Let me zoom if it's not visible. And this is the resources. So in the resources, I am just mentioning that my customization should monitor or should take care of deployment as well as service inside its hood, because I have created same YAML manifest file inside this directory. If you have another YAML manifest file like daemon set, secrets, etc., so you can include those as well. Apart from this, I have added common label, which I have already explained in my slide as well, that we can add common labels as well as some selector type. So here I have mentioned those as well. So I'm adding a label which is app, which is default here, and name prefix I'm using default. So this name prefix here means that whenever any pod of this deployment is created inside this default namespace, then the pod should have default as a prefix, and the label of my pods say should have the value key value pair app default. So this was for the base section. So um, yeah. So now let us check for overlays. So for overlays, I am deploying my application in two different namespaces, or you can say two clusters. One is dev and another is prod. So let us check for the dev. So for the dev, same deployment as well as same service file I have created. The only difference is the replica of my dev application would be 3 here. And here I am using a customized Docker image, which is specifically for this dev namespace only. So this container or this image should work only inside my dev namespace. So where I am declaring my dev namespace, so I am declaring all the details or the patches inside this customization.yaml, which I have already created in my base as well. But here, something are different from the customization which I have described in base. So API version and kind, these both are same, but inside this, I have created resources, and in the resources, I have mentioned the path of my base directory, because the use of customization is only that we are using a single source of truth for our application, but we are just doing some simple or minor patches or some minor modification specifically for the namespace or for the cluster or environment, whatever you want to say. So we are like referring all the YAML manifest file inside base directory. After this, as I have created some modifications in my deployment-dev YAML manifest file, so I have added this file inside patch strategic merge. So this is a field for customization, and I have used that only. After that, I am using name prefix, which is dev hyphen. So every pod of my dev namespace should have a prefix of dev before that. And here is the thing, namespace dev. So this is how I can isolate my dev application or my application for dev namespace. And same thing, I am adding my common label as well. So this is also how I can isolate my application by adding the custom labels here. In the service-dev, I have created the service, but nothing is different from the base image or from the base directory. So I have commented out. The only difference I have modified is inside this deployment-dev. So this is the structure I have created for the dev namespace, and this is for the prod. So in the deployment-prod YAML, I am using 5 replica of my application, and this is the custom Docker image for prod application as well. Same thing I have done in customization for prod. Like I am referring all the base YAML manifest file from my base directory. Uh, Patches I have done for my deployment-prod YAML. I'm using prod hyphen as my name prefix, and all the application or the 5 pods which I have declared inside this should be created inside namespace dev, sorry, prod, and it should attach app prod uh, label for all the pods which run within prod namespace. So this is the structure I have created for this proof of concept here, which you can also follow. I will definitely provide the link in the description. And I want you to try and modify this template and try to add some more YAML manifest file and more complex conditions. So yeah, let us directly jump to Killer Coda for the Kubernetes cluster. Mm, yeah, so let us select Kubernetes 1.30 version for our playground, and let me copy or clone this repository here. Copy this, git clone, paste this. Okay, so let us move. Okay, although Kustomize is already like pre-installed with kubectl, but sometimes it give issue. So I have provided one-liner installation for Kustomize. So just apply this, and it will install as well as configure Kustomize inside the correct directories. So it has installed 5.4.3 version of our Kustomize. Okay, so yeah, let me open tab 3 tabs. So what is my intention here is in the tab 1 we will is run base uh, directory application, which is run inside default namespace, and tab 2 will use we will be deploying dev application, and in the tab 3 prod application. So let us move inside this directory, which is customize-demo. Move inside this, customize. Yeah. So now we just have to run this command. We just have to give the path for the base and see. It has created the service as well as deployment, which we have described inside our base directory. So let us check if our pods are running or not. Kubectl get pods. So yeah, our pod is running, and here you can see the name prefix which we have given default hyphen inside the customization.yaml. So it is following the same patch there as well. So see, name prefix we have given default hyphen. So each of the pod which will run inside this default namespace using this customization, then it will always have this uh, prefix. Let us check the service as well. Sorry, kubectl get service. So here also default hyphen prefix is been added to the service, and this is the port, which is 31369. So see, as I am only using a Nginx version, Nginx image of version 1.14.3 or 2 maybe. So it has successfully displayed the page for Nginx application. So we have successfully executed our base application inside default namespace. kubectl, let us also check the pods label as well. kubectl describe pod, and the pod is default and hyphen hyphen show labels. kubectl describe, maybe I have to like write this kubectl, I guess kubectl get pods. So yeah, sorry. The correct command is kubectl get pods, then the pod name, and then this flag hyphen hyphen show hyphen labels. So here you can see that it has attached this label which we have declared in customization dot YAML for base app is equal to default. So here like we have verified and validate that it has correctly attached the patches which we have described or declared for base application. So now let us deploy our application for dev namespace or the dev application. So for that, we have to again move inside this directory, then cd customize ls. Okay. So for that same command, we have to write kubectl apply hyphen k overlays and dev. So here it has given us error that when it was creating those resources for dev, the namespaces dev was not found. So for solving this issue, we just have to create the namespace for our dev application, which is dev. So we have created the namespace. Now let us again execute this command and see. It has given us warning, so we can ignore it. It's nothing important. And so here you can see that it has created service as well as deployment. So let us check our pods, deployment, get pods for dev namespace. So here you can see that it has attached dev hyphen prefix for all the pods for our dev application. So inside dev, I think we have given three replica of our application to run. So yeah, we have created three replica and it has attached dev hyphen prefix as well. Now let us also check uh, the labels as well, which we have declared for this app. Hyphen hyphen show labels and hyphen and dev. So here you can see that app is equal to dev, which we have mentioned inside this customization.yaml. So yeah, so it has uh, successfully attach the prefix for the pods as well as the labels. So now let us access the application as well. It's just a simple Nginx based application I've created which just display a simple message. So this is the port for our dev application, which is 31281. Let us access this. So yeah, here you can see hello message from our dev environment. So yeah, we have successfully deployed our dev application as well. Now it's done for the prod. Again, we have to move inside customization, then customize, sorry. Yeah, okay. So same command, kubectl apply hyphen k overlays hyphen prod. So we have again got the same error because prod and dev namespace was not created. So let us create a namespace prod here as well. Now apply this command. So here again we can see that it has created the service as well as deployment. So let us access the pods for this namespace. So here you can see that it has attached prod hyphen name prefix for our pods and the 5 replica of my application was running, which we have declared inside the customization and as well as inside the deployment.yaml. Again, let us also check the labels as well. Qctl get pods, take one, let us take the middle one, and hyphen n should be prod, and it should show labels. So here you can see that it has successfully attached our label as well, which is app is equal to prod. Now let us access the service as well for this application. So the port allocated is 30274. So yeah, here you can see we have successfully deployed our application, and we are also getting the correct message, which is hello message from prod environment. So we have successfully deployed our application within each of the different environments, or you can say namespaces, in our demo. So this is what we are trying to achieve using Kustomize from this diagram as well. So using Kustomize, we have deployed our application to dev as well as prod namespaces, and we have also followed this flow diagram, uh, which is consisting of base as well as overlay components. So yeah, I hope I was able to explain you how Kustomize work and how you can create configuration management for your all the application, because it will definitely help you by reusing the same YAML manifest file, which is same for all of your customer for all your cluster, and you just have to customize or do some minor modification for each of the environment or namespace you want to deploy your application. So yeah, thank you for your time, and have a nice day.